Ionic bonding, a method of bonding two substances which are the metal or transition metals such as calcium, magnesium, and copper, with non-metals such as chlorine, sulfur, and oxygen, and radicals such as sulfates and nitrates. So firstly, we need to understand the concept of noble gases, which are neon, argon, helium, krypton, xenon, and radon. Now what's special about these gases is that they're very unreactive and stable. That's because the electron configuration is filled. The outer shell has no more space for any more electrons. Therefore, it is unreactive. However, only some out of all the elements available in the periodic table are actual noble gases. So we'll be exploring how these metals react with these non-metals. So for this example, we'll be using magnesium as a metal and nitrogen as a non-metal. So firstly, magnesium has 2 extra electrons on its outer shell, which means that it's not completely stable. For it to be stable, the easiest way for it to be stable is that it should mimic the electron configuration of neon. That is the easiest way for magnesium to mimic a noble gas and become stable. So when it's reacting with nitrogen, the best way for it to react with it is that if it gives away its 2 electrons to nitrogen. And now this works for nitrogen as well because it is also getting its electrons filled to mimic neon, the easiest way for it to become stable. However, because magnesium only donates 2 electrons to nitrogen's available space, that means there is still 1 electron needed to be filled in nitrogen for it to become neon. Well, mimic the electron configuration of neon. So therefore, another magnesium is needed. So therefore, this magnesium donates 1 of its electrons to neon. However, now this magnesium has 1 spare electron, so it donates it to a whole new nitrogen. However, 2 empty spaces are filled in this nitrogen, and therefore another magnesium donates both of its electrons to fill all the available spaces. Therefore, every single one of these atoms in this compound is now mimicking the electron configuration of neon. Therefore, we can say that magnesium plus nitrogen makes or produces 3 magnesiums and 2 nitrogens. However, something special happens to these elements. When an electron is taken away, the electric charge for magnesium is now not neutral. Since magnesiums are negative charges, this magnesium becomes positive because the protons and the electrons are imbalanced and there are more protons than electrons in this element. Therefore, it actually has a positive charge by 2, as in 2 more protons than electrons. Likewise, a similar thing happens for nitrogen. 3 electrons are actually added in the ionic bonding process, and therefore it becomes negative by 3 since electrons are a piece of matter with negative charge. So it is negative by 3. And then if you apply this to all of the atoms in the molecule, you'll find that the positive charge is the same as the negative charge, which is 6 and 6 for both. Now, this charge between these 2 molecules is a thing that between these 2 atoms is a thing that holds them together as positives and negatives attract. So they are bonded through the process in which um, this negative charge meets a positive charge and bind together, and now they are fairly unreactive, and it would take electrolysis to separate them again. And the shift of electrons within this whole molecule creates energy, and that can be heat energy, light, or light energy. Not in this case, but in many other cases. Now, what do you call a positive ion? And an ion is an atom which either has a negative or positive charge attached to it. So a positive ion would be called a cation, and a negative ion would be called an anion.